Hello everyone. Never you forget I'm the chemist who loves Mary. You get. Now in the course of this video, I'm going to be solving this question. Yeah, this question will take a lot of time because there are a lot of things I want to unravel, a lot of mysteries to unravel. And you that is writing JAM or any chemistry related exam, you really need this question. You get. Now let's really read this. It says when 5 grams of potassium nitrate is dissolved in 100 grams of water, the temperature of the solution drops from 25 degrees Celsius to 21.2 degrees Celsius. Calculate the heat of solution per mole of the potassium nitrate. We're giving specific heat capacity and we're giving what? To be 4.2 joules per gram degree Celsius, and we're giving molar mass of potassium nitrate to be 101 gram per mole. Now, when you see questions like this, you don't care if it's long or not. You have to understand where it's coming from. Now we're told to calculate the heat of solution. Now, first of all, what is heat of solution? Heat of solution, it can be used interchangeably with what? Enthalpy change. And in the part 2 of this video, you can see I wrote part 1 here. In the part 2 of this video, I'm going to be explaining and solving a question under what? Enthalpy change. Now let's focus on heat of solution. Now what is heat of solution? You can say heat of solution is the amount of heat energy absorbed or released. Energy absorbed is the amount of heat energy absorbed. I'm coming now. Amount of heat energy absorbed. Okay, the heat is very important. Please watch this video till the end. You will gain a whole lot, especially those that will be writing JAM or any chemistry related question. Endothermic here. Okay, what's wrong with me? Absorbed and released. All right, released. Exothermic. I will explain. I'm coming. Let me define it again. Say heat of solution is the amount of heat energy absorbed or released when 1 mole of a substance dissolves in a solvent. When 1 mole of a substance or a solute dissolves in a solvent, it is the amount of heat energy absorbed or released. So you can therefore, don't forget the unit of heat of solution is kilojoules per mole. Alright, kilojoules per mole. That of enthalpy change is just kilojoules. Don't worry, part 2 of my video, you just have to stay tuned and watch for part 2 where I'll be explaining enthalpy change. Okay, now let's go. Now when we say heat energy absorbed, what do we mean? Heat energy absorbed is what? Endothermic. It means energy has been absorbed, heat has been absorbed. When we say endothermic, it means heat has been what? Absorbed. But when we say exothermic, we mean heat has been released to its surroundings. Now in this question, you have to know if the reaction or if what occur is endothermic or exothermic. How will you know? You will know if there is a decrease in temperature, and secondly if the surrounding becomes cool. Depends on how they set the question. Now let's see how this question was set. It says from this point the temperature of the solution drops from 25 degrees Celsius to 21.2 degrees Celsius. You can see it drops from 25 degrees Celsius to 21.2 degrees Celsius. There is a drop in temperature, therefore endothermic. That is, heat energy has been absorbed. But assuming there was an increase in temperature, it will have been exothermic, which indicates that heat has been what? Released. You get, heat has been released. So therefore the solution drops from 25 degrees Celsius to 21.2, and when temperature drops, the surrounding tends to be cool. You get. So therefore heat has been absorbed, and that indicates endothermic. So you can say this question is what? Endothermic. Okay, now let's quickly go to solving of this question. Let me not waste too much time. Let's bring out our parameters first of all. It says when 5 grams of potassium nitrate is the solute. So you can say mass of the solute, which is what? Potassium nitrate is what? Please let's divide this place into 2 so that there will be space. Will be what? 5.0 grams. Alright, now the mass of what? We're given mass of water, which is the solvent. Mass of solvent, which is water, H2O, to be 100 grams. Now in solving this, we need to know the total mass. Total mass will now be what? Mass of solute plus mass of solvent, which is 5 plus 100. It was 105 grams. Now this is the mass we are going to be using. Alright, now what did he say again? He said the temperature of the solution drops from 25 degrees Celsius to 21.2. from 25 degrees Celsius, you will agree with me that the initial temperature is what? Is 25 degrees Celsius. While the final temperature, alright, the final temperature is what? 21.2 degrees Celsius. 21.2 degrees Celsius. Therefore, in the question we are going to be using, we need to what? Find the change in temperature. The formula we're going to use, we need to find the change in temperature. Yeah, the change in temperature will be final temperature minus initial temperature, which is 21.2 minus 25, and that will give us minus 3.8 degrees Celsius. Now, for the chemists or very intelligent persons, you will be like, why don't we convert this thing to Kelvin? Well, to be honest, it's the same thing. Now, when finding heat of solution or any other what heat, depends on what you are solving for. That is, it could be enthalpy, it could be heat of solution. Whether you put degree Celsius or degree Kelvin, it's optional. That is, it's up to you. But when solving for gas laws and absolute temperature, you must convert to Kelvin. But when solving for heat of solution, enthalpy change, it does not really have to do with what, or it does not really concern what you're changing it to, whether degree Kelvin or degree Celsius, because when you do this, you will get the same thing. Now, what do I mean? Now, when you are converting to degree Kelvin on the norms, you are adding 293, right? Now, if I add 293 to this, I will get 0.2, 3 plus 1, 4, 9, 10, 11, 1, carry 1, 2 plus 1, 3. Alright? Minus, I will add 293, 5, 8, 9, 10, 11, 1, carry 1, 2 plus 1, 3, 318. When I minus this thing, I will still get what? Minus 3.8 degrees Celsius. Degree Kelvin, sorry. You get. So it's not really optional, but I just advise you to use what was given, which is degrees Celsius. Okay. Now, specific heat capacity denoted by C is what? 4.2 joules per gram degree Celsius. Okay. Now, molar mass. The molar mass of what? Sodium nitrate, of potassium nitrate is 101 gram per mole. We're already giving molar mass. Now let's quickly put this into solving. Now remember, I never give you the formula from the beginning. I'm very sorry. Now, heat of solution is denoted by what? The change in the heat of solution. You can see this. This is the way we write it. Given as what? Q, which is the heat, over N, which is the number of moles. So we have to know Q first. Let's leave this side for the solving. Let's leave this side for this place. And let's move to this side. Now, Q is what? MC change in theta. Alright. Now, our mass was 105 times the change in what? What am I saying? The specific heat capacity is what? 4.2. And the change in temperature is what? Minus 3.8. Okay. Now, when you press your calculator, you will get this figure, minus 1675.8. Now, this is where things get crazy. This minus 1675.8 will change to plus 1675.8. Now, the likely question will be how or why. Now, this is for the solution. Remember, this question is endothermic, and sorry, I forgot to point it out at the beginning. I'm going to point it out now. When they say endothermic, just know that whether it's minus or plus, it should be plus. That is, when energy is being absorbed, it is positive. While if energy is being released, which is exothermic, is negative. Okay, to quickly write this down, endo, positive. Exo, your answer should be what? Negative. Your final answer, your initial answer, endo positive, exo negative. So when heat is being released, negative. When heat is being absorbed, positive. Now, in the question, you will agree with me that it says when 5 gram of potassium nitrate is dissolved in 100 gram of water, the temperature of the solution drop. So the solution was releasing heat. This negativity, this negative sign means what? The solution released heat. This negative sign means the solution released heat. But now, when 5 gram of potassium nitrate, when the solute was added, there was a decrease in temperature. So when solute was added, what? It absorbed heat, thereby decreasing the temperature, which is endothermic. So we'll have a positive sign here. You get. So therefore, our Q is this. Now we have to find n, which is number of moles. Now number of moles is given that mass of the solute over what? Molar mass of the solute. Of the molar mass of the solute. And the mass was given as 5. Remember, we're not using 105, we're using mass of the solute, which is 5. And the molar mass is what? Is what we have not calculated for. Sorry. Okay, it's already given. They've already helped us to calculate it. Okay, now we have 5 divided by 101, and that will give us 0.0495 moles. Remember, this is what mass is 5 grams. Molar mass is given as gram per mole. Gram cancel gram, we are left with mole. Okay, now let's input our values. Now, heat of solution. Heat is what? Positive 1675.8 divided by the number of moles, which is 0.0495. And when you press your calculator, you will get, yes, this is what you get, 33,854.5. Now remember, this heat is in joules and this is in mole, so we have joule per mole. But mole. But initially I told you that the formula is kilojoules per mole. Heat is measured in kilojoules, so we are dividing this by 1000. When we divide it by 1000, you will get 33.85 moles. Kilojoules per mole. Kilojoules per mole. And this is heat of solution. Now options could be negative or positive, you get. So after solving everything and you are still having a negative answer, if the reaction is endothermic, depending on the question, you have to change to positive, and that will be the correct one in the option. But if the reaction is exothermic, which means heat is being released, you change to negative. But in this question, it is what? Endothermic, which means heat is being absorbed and it's carrying a what? A positive sign. A positive sign. So therefore one side is 33 plus 33.85 kilojoules per mole. 33.85 kilojoules per mole. Thanks for watching. If you find this video helpful, click on the plus sign to follow me, share, like and comment. And if you go to my bio, you see the link that will take you to my YouTube channel where you can subscribe and click on the notification bell, so whenever I release my videos, you'll be notified. And before we go, please, sorry I forgot, this is a practice question. It says 5 grams of ammonium triazonitrate 5 on dissolution in water cooled its surrounding water and container by 1.6 kJ. What is the heat of solution? Now this question is straightforward. You just have to find the number of moles, which is the mass, and you have to solve for the molar mass. And for them not to stress you, we're already given the heat. You are not going to use Q equals to MC change in theta. They've already done that, and you got 1.6 kilojoules. And remember, to know if it's endothermic or exothermic in relating to number 2, it says cooled its surrounding water. Now for something to cool its surrounding water, it means that it has already absorbed it. Heat has been absorbed, making the environment to cool, to be cooled, making it to be what? To lose what? To be a decrease in temperature. For there to be a decrease in temperature. So you get. So for the water to cool its surrounding water, it means what? It is endothermic. So this reaction is endothermic. I've able to answer number 2. So you do number 1 for me and drop it in the comments. Stay tuned. God bless.